Without further ado, I'll introduce our first speaker, speaking on using technology or technological and web-based solutions to modernize the long-term water level monitoring network, Jason Ramage. Jason, the floor is yours.
All right. Good afternoon. Can everybody hear me okay up here? Good. Thank you for that introduction. My name is Jason Ramage. I'm with the US Geological Survey. Been working in the Gulf Coast Program Office for about 13 years. That's in the Houston region. And for most of that time, been working in the groundwater program there, primarily working on presenting annual water level altitude maps for the aquifer system there in that region. And then a few years ago, we decided we needed to sort of update or modernize our workflow, our processes, and data collection for that program. And so a little bit about that monitoring network. We've got about 650 wells that we monitor and collect water level data at in a 11 county region. This is in Harris County and all the surrounding counties. Most of those water levels are collected in public supply production wells, but we also have some irrigation, domestic wells, and monitoring piezometers. And because it's such a large network, we have cooperators that we use. A lot of you probably saw Mike Turco speak yesterday, General Manager for Harris-Galveston Subsidence District. So we work with them as well as the Fort Bend Subsidence District, City of Houston, Lone Star Groundwater Conservation District, and Brazoria County Groundwater Conservation District. So again, we have quite a large network here. It takes a lot of time and effort and resources for us to go out and collect all of that data. So here we've got, these are sort of some of the methods, our sort of old school methods that we were using up until really just a few years ago. We've got paper forms, that sort of top middle picture there. Difficult to see, but that was an old form that we used to use. I think they were in 4x6 format. And when I started as a student, in fact, one of the tasks that I was given, of course, all the sort of tedious task is given to all the students, right? So one of the things that I had to do was to take the previous year's field forms, all 650 or so, give or take, copy all of those, cut them down to size, hole punch them, organize them into these little binders. And not only that, but also take all the hand-drawn maps that were created to help locate the wells, cut those out, and with a glue stick even, slap those on the back of the field forms. And so this was something that took me probably easily a week, if not 2 weeks. It was a pretty tedious task. I did that for a year or two, find a different way. So in fact, what I did was I created an Access database to help sort of automate that process and went to a standard 8.5 by 11 sheet, which is the kind of top right, I believe. Yeah, top right image there. Pre-populated some fields for each well, and I could do that, produce all of those 600 plus field forms in, a matter of a few hours. So big improvement there. So that was great, but it still wasn't really the ideal workflow. I still had to deal with all the hand-drawn maps and so forth and kind of organizing those into what we call field trips and so forth for our field people. So in addition to that, we also had these Garmin GPS units as well as these kind of handheld PDA units, and we had one for each of our field personnel. Each of those needed to be updated, obviously, with its software and the little waypoints and everything else. And so, again, that was sort of something that was really a tedious process for keeping up with all of our field personnel. And, I just kind of was always looking for ways to update that process. And again, a couple of years ago, kind of found another way to go about collecting our data. And so I got, when I started talking about this, I got kind of a lot of looks like this guy in the meme here, from the old school people of they weren't really too keen on updating their processes, but I think they've come around to it since then. So found a cloud-based data collection platform that allowed me to build an app that would suit our needs. And so we built a mobile field collection app, and we're basically able to take all of those GPS, the GPS, the PDA units, as well as the field forms, and just integrate those into a single mobile field collection app. In our case, what we used were just our cell phones. These were things that all of our field people already had. And so the nice thing about that, obviously from the standpoint of not needing those other devices and the field forms and so forth, we were able to have sort of a central data repository. And so that means that all of the well information, all the background or back-end data I could update that from an essential repository and then feed that out to all the devices. So that made things from a project management standpoint a lot smoother for me. And then not only all the back-end data, but all the data being collected is all coming into that same data repository. And what I'll show next is that it's really just a simple spreadsheet format. So again, all of that data is coming into a single location. It's structured data, which then down the road makes it much easier to manipulate that data processing, and so forth. So in addition to all of that, we're also saving money and not having to purchase as many or purchase the GPS units and all those handheld units and spending all the time updating those on a regular basis. So it not only increased efficiency on that end, but also increased efficiency with our data collectors, so the people in the field. And so the nice thing from that standpoint is they're all seeing the same data coming in. So for instance, they can see in sort of a map view, they can see where data still needs to be collected, where data has already been collected. Previous to this method, we had more of a, I guess I would call it a dispatch kind of method. People would go out in the field, collect some data, and then call me up and say, hey, I'm done with this. Where do you want me to go? They don't need to do that. They can manage their own time a lot more easily by just using the app, and we'll see that here in a minute. And so hopefully everybody can see this kind of okay. This is actually just a video of an example of the app. On the left-hand side, it's just a spreadsheet. And so within the survey, at least currently, we're using the Google environment. So this is a Google sheet, cloud-based sheet, or cloud-based spreadsheet. And then on the right is the actual app, as you might see it on your cell phone. And so, let me see if I can play this video. And so you'll start seeing the app scrolling. You get a map view, for instance. If you click that map view, you get a feel for where the app is, or excuse me, where the well is. There's a little icon at the bottom which will even open up Google Maps for you, give you driving directions, tell you how far that well is. Other information such as the well name, well number 2, for instance, might be how we communicate with the well operators. There's photos, time and date stamps on the photos. In this case, we have airline calibration, measuring point values here, and their descriptions. And here we have meter readings. And then at the bottom, we have water level history, so you get a feel for, historically, what are the water level measurements at that location. And then now we can enter in a new measurement. We'll select the equipment ID, which we'll use later for corrections to the calibrated equipment. We're collecting a non-pumping level here, and then we're going to enter in a hold of 235 feet, for instance, with our steel tape. Enter in our cut values, and then here select our measuring point, and then it gives the value, select that, and then the water level then is calculated for you. And then you can select accuracy. If it's a pumping level, we might collect the GPMs. And then put any notes. And here I'm just putting in well is off for 3 hours. And we'll save that, and then what we see within a matter of a few seconds, all of that data that we just filled in there will come back to that Google spreadsheet and write that as a new row. And so the nice thing about that so again, in each column, for each field that we collected in the app is being written to that new row. So again, everybody's out in the field, they're collecting data. If I'm, as a project manager, not in the field, I'm seeing all of this stuff come in. In fact, I will just leave that window open on my computer all day and just kind of periodically check it and be able to see almost real time what's going on out in the field. And if I need to call up anybody in the field, I can say, hey, something looks a little funny, maybe collect another measurement or whatever the case might be. So really a big improvement from a project management standpoint on that. And then the other nice thing about that is that, again, with the structured data format, and particularly as it's coming in kind of real time, I can pull all of that data into a scripting language. And my preferred is R, but we also use Python scripting for any kind of data processing or data manipulations. It makes it easy to archive that data, like kind of on a daily basis. I might pull that in, download it, and just archive the data that has been collected up to that point. It's all standardized structure. Makes it easy for data exploration, as well as what we'll see next is dashboards and project management type tools. So one of the things that I didn't build into the app here is being able to include corrections to our steel tape corrections to our measurements. But what I decided was it would be much easier and standardized if I was to pull in all the information or all the data that had been collected at the very end, run that through a Python script, and sort of apply all of the corrections that's needed, and then very easily put in or come out with a structure that can go onto our National Water Information System database and makes all that data public at that point. So it's just a lot more of a streamlined process here, and even more real time. And so this is an example of an R Shiny dashboard. A lot of you may be familiar with these already. And so I use this from a project management standpoint. Again, specifically since all this data is coming in almost real time, I'm kind of on a daily basis able to look at this dashboard, help me to kind of keep track of what's going on in the field, as well as provide this dashboard as just a web link to my managers who can, at any given time, if they're interested, go in and see what our progress looks like and see what the data looks like coming in. And so again, this is sort of another video example. So the first thing we see here is a map view. All the blue dots are at this point representing wells where data has already been collected. The red dots are representing wells where what we call UTM, or unable to measure. So I got to get a visual idea of where all these wells are, where maybe the well was down, maybe there was some tooling in the well, we just couldn't collect a measurement for whatever reason. And then there's some black dots there where we still need to collect data. And then a little widget giving me an idea how far are we to completing all of our measurements. So we're up to 96% at that point, as well as some other relevant numbers. And so they are all grouped by aquifers. So we've got the Chico, Evangeline, and Jasper. Those are all selectable. So all of this stuff is kind of interactive. And then we'll look at the stat. There's sort of another tab there for stats, so we can look at, I could get a feel for what the measurements look like. And so, for instance, probably difficult to see. I'll pause it really quickly. On the left-hand side, there are selections for field trip names, what really amount to all the wells within a county. So I can select any of those counties and just get a quick view of what are all the measurements that are coming in for that particular county. Oops. Let me go back really quickly here. Okay, so then the next thing here are hydrograph plots. Not the prettiest things, but just again from a project management, it will pull in all of the hydrograph data for all the wells that exist. In this case, I'm pulling in Fort Bend wells and Evangeline wells within the Fort Bend County. So again, just get a quick overview there of the hydrographs. And then I think, again, from a project management standpoint, this is quite useful for me. I keep messing that up, sorry, y'all. This is quite useful for me as well as my managers. We've got the graph showing in the blue line, that's the 2018 data. So what it says is that on the x-axis, that is date, and then on the y-axis, that is cumulative number of measurements that have been collected through time. So we get a feel for 2018 in the blue line, we get a feel for how quickly we're collecting all that data, and then the orange line next to it is for 2019. And so that sort of long sort of flat period there was during our last government shutdown, where we were not able to work, and so we were sort of scrambling to collect all the rest of our data up that point once we finally got back to work. And so we did. And it was nice to be able to show my managers that we were putting the resources into the data collection that we needed in order to finish up the measurements on time. And then the tables on the other side are scrollable, but they are the data that make up these make up this graph. And so you have date on the left-hand side. The middle column shows just number of measurements that were collected that day, and then the count column on the far right is cumulative number of measurements collected for that day. So once we collect all that data, of course, we have to do something with that. And so really what we do is produce annual depictions of water level altitudes for the three aquifers, and as well as short and long-term changes. And we've been collecting data and doing these maps for over 40 years now. And so what we'd always done historically was produce these printed maps. They came out in these 17 by 22 large plates, and they looked really good. They were great maps. I think they were really useful. Our cooperators all seemed to always like them. But what I think we figured out was that oftentimes, we would present them, they would look at them, everything looks, as expected or not, or what, and then they would fold them up and tuck them away and maybe looked at them periodically, but not all the time. So, there was that aspect, and then they're also not very interactive, and then also within that, they're not very easily explorable. So we decided, in order to modernize that product, we would produce a web app that would take all of those previous 40 years of data, put them all into a single location and make it interactive for the user, make it accessible, all in this one web app location. And so the Texas Water Science Center put together this web app, and if I've got the time, I guess I'll open that up maybe quickly here. Just do a quick, no, I'm not connected to the internet. Well, so we have a booth outside, and we can demo that at the USGS booth as well if anybody'd like to see that. But it does take all the previously published contour and point data, makes it interactive. You can select, see what the water level altitudes were for any given year, as well as see what any changes were. And so you get the visual aspect plus all of the data associated with it, as well as subsidence data. And so the next, I guess the next level from that, now we're going to start doing a geostatistical reanalysis. We've started going down that process. Historically, we've always, what we've been doing for probably the last 15 years or so, pull all that data in, put it into a GIS system, produce raster data sets from the data, and then contour that data. And so we would have to then manually adjust those contours based on what the data were telling us, our historical knowledge, and so forth. But here we want to look at doing a geostatistical reanalysis of that, because it then makes it a little bit more transparent and reproducible, but also gives estimates of what the water levels are, as well as a quantifiable value for uncertainty. And so again, when we're manually adjusting these contours, the subjectivity is a little bit unclear as to why we're doing that. It makes, it might be clear to us when we're producing these maps, especially as we've been doing them for so long. And this is an image, by the way, of the web app previously mentioned. But anyway, so we manually have to adjust those contours, and so we want to try to remove some of that unclear subjectivity. And it's also laborious. It takes a lot of iteration to go through and relook at all the data points and readjust all those contours. And so this is one of the outcomes from that geostatistical reanalysis. We want to try to automate this process a little bit more and document that subjectivity and include that uncertainty. And so the top right image there is the results from the geostatistical reanalysis for the data set from the 2010 Evangeline measurements. And so what I did was the blue lines are the previously published contours, the contours we published in 2010. And then I colored the raster set to equal the same contour interval. So we have 50-foot contour interval here. And so it does a pretty good job, really. You can see it kind of stays within the contours quite well. There's a small area, I don't know if any of you can see the mouse, there is a small area here that maybe didn't do such a great job. The colors for the estimates don't have the same contour surrounding this area. But when we look at the other image there, that gives us what our level of uncertainty is. And so where we see all of the bright yellow points, specifically at our data points, our uncertainty is very low. But as we start deviating or getting away from those data points, our uncertainty then becomes higher, and we start seeing these reds and kind of purple colors. And so again, maybe difficult to see from your location there, but where we have maybe not so great estimates, we can see that our uncertainties are fairly high. And so really what that tells us is, well, we need better data control there. So that's the other big benefit from doing that is visually that kind of makes sense, but we can quantify what our uncertainty is and where we need to increase our network. So actually I think that's all I've got. And want to do questions? Yes.
Hi, I'm Jevin Harding. I just had a couple questions. One is that your program looks great for some of the districts that we work with. Is that ever going to be publicly available, or is that just USGS internal?
No, it's actually a platform. It's not a USGS product. It's just a platform. It's called AppSheet. You can look it up, and then anybody can use it. It's just something that fit our needs, and it allows you to build the app in the way that you want.
Okay, so, but you made some additional adjustmustments to it.
Well,
correct?
I just built the app to collect the data that we needed, really. So it's completely customizable for your needs, really. Okay,
but otherwise it's like a spreadsheet program, or?
Yeah, it uses a cloud-based spreadsheet as the data backend. Okay. So what you do is, so again, in our instance, we use Google Sheets. That is a cloud-based spreadsheet, basically, and I was able to connect the app with that, feed whatever data to the app that was needed, and then get the data back from the app into that spreadsheet.
Gotcha. Do you ever worry about losing data? Because I know USGS has pretty strict standards for data collection. You
know, there was a time, I think it was this year, where there was something that was going on weird with the servers, and I did notice, I was in the office, and I'm like, why is there no data coming in? There turned out to be an issue with the Google servers. And so what happens is that all the data, that if they're not getting synced back, all the data are still being saved within the device itself. And so it's all recoverable. And so, there was a period of a few hours where I wasn't seeing data coming in, but after the whatever the issue was with the servers got fixed, it all flooded back in, and it was not an issue. And all the raw data files were still available for me as well.
Okay.
So no, I haven't really had there hasn't been any issues. I've been using it now for 2.5 years, something like that. Really haven't had any major issues like that. So it's been good.
Cool. Thank you.
Sure.
Any other questions from the floor? Seeing none, let's thank Jason.
All right.
Jason, thank you.
Thanks.